Good morning, everyone. I wish everything is going great with you. Okay, based on the decision of the President of the University of Bahrain, you have heard about it, right? So all exams and even lectures will be on campus. So we are supposed to gradually return back to have lectures in classrooms. So I've decided to have lectures starting from the next week, inshallah. So I'm gonna be in campus. Let me just write this in the chat box. There will be lectures, face-to-face lectures. Yes, I'm gonna have it, but anyway, I'll be there, Qasim. And I'm gonna have it now. Just let me wait for others in the end of this lecture, because you know that's attendance for the lecture will be just a minute. Only 11 students are here, so it's not fair to have it now. So at the end of this lecture, I'm gonna have a not let we say questionnaire for having it online. How many will be online? How many will be in campus? But they are planning to have all students back to the university campuses by the end of this semester. Okay, so there is a plan to have it. Still, some students prefer to have it online, but they will be back at the end of the day. All right, now or later, it will be in campus. Anyway, so I'm gonna be there. We will start having lectures in S40 028. This is the classroom. All right, 028 or 021. I'm not sure. Let me just check, because there is for practical and for theoretical. So yeah, I guess it will be in the ground floor in S40 building, the IT college building. And I will be there starting from the next week, okay? Next. Yes, you will have it, Jinan, inshallah. But I will be there anyway. Yani I'm gonna have the lecture in campus or on campus in this room starting from next week. We will have the questionnaire. We will have it, inshallah. I will be there starting from 13th of March. Okay, of March. I'm not forcing you to come there, but I will be there. Oh, sorry, not 2021, last year, to 13, 8 to 22. All right. We will have the questionnaire at the end of this lecture, okay? Because I need to know how many students are gonna attend in campus and how many students are gonna be select online. Because you know we have only 20 students here, and I think we are how many students? Let me just check. In this section, I'm gonna check now. Just give me a minute. 6149. Okay. I can see 37 students in this section. They are enrolled in this section. So 37, I need to know, based on what you have selected in the system, there are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students out of 37. Okay, so we have only 10 students out of 7, sorry, out of 37 selected physical study method, and the remaining selected online study method. I understand that most of you prefer the online method because you know you are used to it now. Because I'm sorry, just a minute. I understand that, but you need to at least try. You need to try it. You need to come. You need to know university. You need to. Is this you haven't been the University of Bahrain campuses before, right? Any one of you? Have you been the university in person? Okay, no. All right, that's why. Okay, some of you, or few students only came to the University of Bahrain previously, but I understand that you prefer online because of some of reasons, you know. But this is an opportunity to come and see and live this experience, right? I believe it will be a good opportunity for you, and we will get to know each other. We will have lectures. We will discuss things face to face. Just think about it, okay? I will have a questionnaire at the end of this lecture, okay? After I finish this, just think about it. Yeah, okay, I understand. Because early morning, right? Okay, but still think about it, okay? Think about it. And inshallah, things will be better later on. Just that we finish this, and then I'm gonna have a questionnaire later on. Okay, so we have stopped in this chapter slide. We have discussed the, let me just move to that slide. We have talked about the relational model. We said a relational model includes number of relations, which means tables, and the table contains number of columns and number of rows. Okay, do you remember the parts of data model? There are 3 main parts. In the previous chapter slide, chapter number 2, we have discussed parts of the data model. Do you remember? There are 3 parts. Let me just remind you. Structural part, number 1, structural part. Okay, parts of data model. Structural part, number 1. Number 2, manipulative part. You remember that? Manipulative part. And number 3, who remembers? Constraint, right? We said set of integrity constraints. Okay, so we have 3 main parts. Based on these 3 parts, we have discussed the structural and manipulative part previously. What are they? The structural part of the relational model will be the relation structure, right? The relation structure, which includes number of attributes, and we mentioned that it's something fixed. The structure of the table or the relation will be fixed, the attribute, and we call it intention of the database. Okay, the intention. So why it's not moving to another slide. Okay. Okay, now. Right, so we have discussed this before. We said the relation includes number of attributes, okay, or columns. We talked about the degree, the cardinality. You remember the cardinality is number of tuples a relation has. The degree is number of attributes a relation has, right? We said the degree can be unary, binary. You remember that, right? And then any attribute will follow the same domain. It's set of allowable values for one or more attributes. So this is the domain. So basically, the structural part will include attributes, then its domain, and it's fixed. Okay, it will follow same structure and fixed. It rarely can be changed unless there is a need to change the structure of the relation. While the manipulative part will be about what? About manipulation, about updating, inserting, right? About what else? Insert, update. What else we can do with the manipulative part? Yeah, exactly, Qasim. We can delete. So what we can do, or which part, which specific part of the relation can be for the manipulative part, can be updated, can be changed over time. Which part? Is it attributes or columns or rows or records, or we call it tuples? So we said tuples are called the extension, so it can be changes over time or the state of the relation. So this is the part of the relational model which can be changed over time. So we said tuples, right? Tuples can be changed. We can insert new records, we can delete, we can update. This is the manipulative part that we can see in the relational model. How about the set of integrity constraints? This is what we need to discuss after a while. Okay, before that we stopped in this slide. We said there is a mathematical definition for the relational model. We discussed the Cartesian product. We said if we have set or sets, we can get the Cartesian product by having the first element from the first set and the second element from the second set. And same with the triples. If we have set of triple, or if we have, sorry, 3 sets, we can have triple elements. Then, sorry, we stopped here, right? We stopped here. Usually, the definition of a relation can be written as xd1 and I equal 1 with an n number. I'm sorry. So relation schema, we stopped here. Relation schema. What is the relationship between the mathematical definition and the relational model? Okay. The relational database can be defined as a collection of normalized relations with distinct names. Okay, so normalized means it has no repeated groups. There is no redundant data. Okay, there is only unique value for each cell. Or distinct, we said distinct data for each cell or value. So it has a distinct name, distinct relation name. So what is the meaning of relation schema? Relation schema, it's a named relation or table, say, consisting of a set of attributes, all right, and domain name pairs. So this is basically the relation schema definition. Named relation defined by a set of attributes with domain name pairs. For example, A1, A2, they are attributes with domains D1, D2. All right. Then the set of this relation schema will be A1 for D1, A2, then for D2, and so on. For example, because the A1 will follow the same characteristics of D1, will include the same domain of D1, okay? So the set will be A1 will have D1 domain, A2 will follow D2 domain, and so on. No, the domain will be set of allowable values for one or more attributes. The domain, for example, for the domain for the numbers, ID numbers, will be set of ID or student ID numbers. For example, student ID, okay? What is the domain of student ID? The domain of student ID are set of ID numbers, which can include a number of characters, and the definition can be, or the description of that can be how many characters, for example, 9 or 10 characters. It will accept 9 or 10 characters starting from a range between then this and this. We can define it this way. Okay, so the domain will be like the identity of each attribute. Okay, the identity. All right, got the point? Or, for example, student name. What is the domain of student name? Yes, it's like yes, Qasim. We can say that. Or the definition, or let's say description of each attribute. It can be described like it's a number, it's a character, or how many characters accepted or allowed for this attribute, and so on and so on. So, for example, student name domain can be what? Can be set of all names or all student names. Okay, and it's the type of this domain will be characters or text. Okay, and it can be accepting more than 200 characters, for example. All right, so this is the meaning of domain. Now in the relation schema, it will be set of attributes and their domains. All right, okay, since it can be defined by mapping the attributes names and their domains, so it's like we are mapping between the attribute names and its domain, then we can have it this way. We can have it like relation will include A1 with domain 1, A2 with domain 2, AN with domain N, such that D1, okay, will belongs to D1, okay, the main domain. D2 will belong to D capital D2, and DN will belong to DN. D small will belong to D capital. All right, so here is an example, a good example. You will get the point here. So you can see this example. A relation is a subset of Cartesian product of the domains of the attributes. Okay, so you can see here in this example, you will understand it by having this example. You will understand the point. See, B00, this relation includes B005, 22 Deer Road. This is a branch, okay? This is a branch relation. This is a relation schema relation schema for what? For the branch relation. Assume that you have how many columns? 1, 2, 3, 4. 4 columns for the branch relation. Okay, the first attribute, the first value for the attribute will be B005. This is the branch ID. Okay, this is branch ID. This is the primary key. So this is number 1, and it will follow which domain? It will be number or character, including 4 characters. Okay, 4 characters. Then comes the address, then the city. All right, then this is, I'm not sure, this is postcode or something. Let me go back to the slide. This is the branch. Going back to this. Yeah, postcode. So see this relation, this one, how we can write the relation schema or relational representation, how we can represent it in the relational schema. It can be represented this way. Okay, if I ask you in the test, for example, I give you relations including number of columns and number of rows, like this one. Okay, and I ask you to represent it in the term of relation schema. Okay, you can do it. Just put branch, okay, and then inside brackets like this. Okay, just let me, inside brackets like this. You can put the first value, B005, 22 Deer Road. This is just subset of this relation. Okay, it's a subset of this relation, or it can be like this. I prefer the second one. Okay, this is called relation instance. Yes, exactly, it's almost the same. This is exactly the relation schema. You are structuring, you are doing what? Building up this relation, you are structuring the relation. Okay, so this is the relation in instance, because it's only one instance of the relation. There are so many records there, not only one instance. But if you want to write it more general, if you have it a more general way, you can just have it like branch number, street, city, and postcode. Okay, in brackets. I'm going to show you after a while. Okay, so this is how we can represent any of the relation instances. Branch number will be what? Will be B005. This is for only one record, okay? Street will be 22 Tier Road. City will be London. Postcode will be this, W14EH. Okay, so this is how we can represent it in terms of mathematical definition of the relational schema. Now, relational database schema. What is the meaning of relational database schema? It's a set of relation schemas. Okay, it has a distinct name. Okay, like for example, we have R1, R2, R3, 2Rn. Any number of relations, set of relation schemas, and you can write it like this is the general term R. The relational database schema R equals R1, R2 to 2Rn. Okay, any number of relations. This is the relational database schema. It can be represented this way. All right, it's easy, just basic mathematical definitions of relations. Okay, now what are the main properties of relation? This is something very important you need to focus on. We have number of properties for relations. We cannot say that this is the relational model or data model if it has no, or if it is not following these properties. Okay, number one, something very important, the relation name is distinct from all other relation names. Okay, so the relational or the relation has a distinct name. This is number one. This is one property. It has a distinct name. All right. Number two, each cell will contain only one value. Only exactly one value. This is number two. There cannot be, for example, one cell with two values. Can I have two ID numbers in one cell? I cannot do that, right? So this is something also, it's like rules, okay? Rules that every relation must follow. So number one, there must be a distinct name. Can I have, for example, branch, two branch relations, branch and branch? Is this possible? No, it's not possible, right? So it must be distinct name. Number two, each cell must have only one value. Okay, there cannot be two or more values in one cell of the relation. Number three, each attribute has a distinct name. Okay, the attribute also has a distinct name. There cannot be two IDs attributes, for example, ID, and then it will be repeated ID. This is not possible, okay? So every attribute must have a distinct name. Number four, values for the attribute must follow the same domain. Values for the attribute must follow the same domain. We said the domain is like describing the attribute, providing the characteristics of each attribute, right? So, sorry. So, for example, if we have an ID, can we accept an ID number with 4 characters only and at the same time we accept 8 characters? Is this possible? This is not the same domain, right? So it's not possible. So there must be same domain for all accepted values for each attribute. Okay, number 5, each tuple also must be distinct. Okay, can we have repeated or duplicated tuples? For example, let me just say names here. For example, Abbas Abdul Majid, I have your record in the student relation. Okay, I have student relation. I have the first one is Abbas Abdul Majid. Then the third one will be Abbas Abdul Majid again. Can we do that? It's not possible. It's not possible to have duplicated tuples. Okay, number 6. No, Abbas, I just give an example. Okay. All right. Yeah, I know because you are not interacting. That's why I said your name. It was the first name in the list anyway. Okay, so 6, order of attributes has no significance. It's okay to have it in any order. All right, so it has no significance. Even order of tuples has no significance. Okay, but theoretically, just theoretically, practically, it has. Yeah, we can say it has significance because sometimes we need to have it in the same order with the, for example, employee number 1 cannot be like the ID numbers can be ordered from A to Z, for example, this way, or student number will be ordered in the list and the student list. Practically, it has significance, but theoretically, it has no significance. But we can say that all attributes, order of attributes and order of tuples has no significance. Okay? What else? What else we can see as properties for the relation? Number 8. Number 8. Relations do not contain repeating groups. We mentioned before, so no repeating groups. No repeating groups. Okay? We said tuples cannot be duplicated, right? Or even any redundant data must not be there. no duplicated data must be there in the relation, because this is something we call normalization. Normalization. What is the meaning of normalization? Normalization means that there will be no repeating groups or redundant data within a relation. Okay, so the relation that satisfies this property, we can say it's normalized to its first normal form. First normal form. Yes, yes, exactly. Because, for example, we cannot have two postcodes for the single branch, right? It's not possible to have two postcodes for one single branch. Okay, so got the point? These are 8 properties for the relation. Let me repeat it again quickly. The relation has a distinct name. Okay, only one value in each cell of the relation. Each attribute has a distinct name. Each tuple. Okay, let we start with a distinct. Okay, each relation has a distinct name. Each attribute has a distinct name. Each tuple is distinct. Okay, which means no duplicated tuples. So distinct 3 for relation, distinct name, for attribute, distinct name, and for each tuple, each tuple must be distinct. Okay, so this is 3. It's easy to be memorized, right? 3 must be distinct. Relation, attribute, and tuple. Okay, what else? Each cell must have only one value. This is something common sense, right? Only one value for each cell. Number 5, all values of each attribute must follow the same domain. Okay, this is number 5. Must follow the same domain. The order of attributes has no significance. The order of tuples has no significance. This is 7. And 8, the relation must not have any repeating groups. And this will satisfy normalization process. Okay? Or this property will be satisfied if the relation is normalized to its first normal form, where there will be no repeating groups within the relation. All right, so eight properties, you need to focus on them. Sometimes I'm gonna give you okay, next time inshallah I will give you an activity for this chapter slide. Yeah, how about the quiz? We need to have a quiz. We need to have a quiz. We will decide about the quiz. We need to decide about the quiz. How about Thursday? Chapter number 2. Quiz in chapter number 2. Okay, let we decide later. There will be a quiz, okay, because I need to have this just 2%, or let's say 4% will be divided later on. Okay, now let's continue. What are the relational keys that can be discussed here in terms of a relational schema? We have different types of relational keys. We have mentioned some of these before, right? We said there is primary key, foreign key, right? But we need to know that there are more types of keys, and there are some features of these keys. So as a general key, the general one, we call it super key. Okay, super key. This is number 1. This is the main key, the main term of relational keys is super key. It's like an umbrella. Okay, what comes first is the super key. All right, what comes first is like the parent of all keys. So this is the super key, is an attribute or set of attributes that uniquely identifies a tuple within a relation. So it's uniquely identify a tuple or a tuple within a relation. So this is the meaning of super key. So we can we say primary key is a super key? Yes, right? It uniquely identifies a tuple within a relation. All right? Okay. How about candidate key? Super key can be also, by short, we can say K. Okay, K. or key. This is the super key. Okay, so candidate key is a super key. It's a super key such that no proper set is a super key within a relation. Okay, and it has two features. It has two features. Number one, uniqueness. Number two, irreducibility. The candidate key. Okay, so the candidate key is a super key such that no proper subset is a super key within a relation. This is the candidate key. And in each tuple of the relation, R is the relation, okay, values of K or super key uniquely identify that tuple. If it is uniquely identified that tuple, then this is the uniqueness feature. All right, the uniqueness. This is the one feature of candidate key or CK. We can just say CK. Okay. While if no proper set of K has the uniqueness property, then this is irreducibility. Irreducibility feature means that no proper subset of super key has the uniqueness property. All right. So these are two features of the candidate key, or let's say two properties of the candidate key. Sometimes a relation has more than one attribute that uniquely identifies each tuple. Okay, what we call it? We call it composite key. We call it composite key. So how many keys we have now here in this slide? How many keys? 3, right? Super key. Super key is the general term of relational keys where it's an attribute or set of attributes that uniquely identifies a tuple. And super key can be candidate key, can be what? Can be composite key, right? So the super key can be a candidate key. What is the candidate key? The candidate key is a super key such that no proper subset is a super key within the relation. And it has two properties. There is uniqueness when it's the super key uniquely identifies each tuple or that tuple, and there is irreducibility where no proper subset of that super key has a uniqueness property. Okay, so two properties for the candidate key. The third type of this relational key here is composite key, which includes or contains two or more than one attribute that uniquely identifies that tuple. All right, so it's a composite key. Composite key. Sometimes we need that. You need to know when we can have the composite key. Okay, when there is two or more than one attribute that is important to be identifying each tuple. Okay, primary key. You know the meaning of primary key. This is another type. Let me just put numbers here. Number 1, super key. Number 2, candidate key. Composite key. And number 4, primary key. Primary key, this is a candidate key that is selected to identify tuples uniquely. Okay, and a relation always has a primary key. There must be a primary key for each relation. Okay, number 5, like what you said, for example, a student number is the primary key for the student relation. Okay, student ID, for example, it's the primary key for the student relation. Okay, number 5, alternate keys. They are candidate key that are not selected to be primary keys. So any other attributes rather than primary key will be known as alternate key. All right, alternate key, unless it has different role, like for example, foreign key. Okay, so 5 alternate keys, alternative keys. These are not selected to be primary key within the relation. While the foreign key, this is number 6. It's attribute or set of attributes within one relation, it matches the candidate key, okay, of some possibly same relation. So for example, it appears and it provides some link or association with other relation, like what you have mentioned here in this slide. You remember when we display this slide? Let me go back. Yeah, it will be referred to, yes, this is it, Qasim. So here is a slide. We have discussed this. We said the branch number is the primary key in this relation, and it will be, or the branch number attribute in the second relation, the staff relation, will be referred to branch number primary key. So branch number in the second relation and the staff relation will be a foreign key. It will matches what the branch number in the branch relation. Okay, so this is the foreign key, one attribute or set of attributes that matches values in the same or in another base relation. Okay, all right. So, okay, let we just go back to here. Yeah, it's already here. We said it matches whatever there in the base relation. Okay, how we can represent the relational schema? So how we can represent the relational schema? This is the way, okay? I need you to focus on this. Sometimes I'm going to give you like relations like that, branch, including number of columns, number of rows, and I ask you to represent, to have, or to write the representation of the relational schema. So what you need to do here is having the name, the distinct name of the relation, for example, branch. Then inside the circle bracket, you can put the attributes. And put this in your mind, you need to underline the primary key. Wherever there is a primary key, you need to underline it. Sometimes you need to underline more than one attribute to be a primary key. How? I'm going to show you now. For example, in the branch relation, there is a branch number, street, city, postcode, and they underline the branch number as a primary key. All right? Okay, then staff, same. Staff number, if name, last name, position, and so on, and they underline the staff number as a primary key. Property for rent, same. Property number, street, city, and so on, they underline the property number as a primary key. Let's look at the next ones. Client is the same, client number, okay. See here, viewing. For example, for viewing, it's important to have two identifiers for this relation, which are client number and property number. Why? Because both are important to be identifying each tuple, right? So both will be underlined, client and property. Got the point? Where we need more than one attribute to identify this tuple, then there is a need to have more than one attribute to be primary keys. Registrations also, registration will be client number and branch number, because a client will be registered in a branch. So both data will be important to identify each tuple, right? So client number and branch number. How we can decide that? We can decide it based on the requirements, all right? Requirements. Okay. Now, you remember when I write this in the chat box, we have three parts of data model. Structural part, manipulative part, and set of integrity constraints. It's deleted here. Okay, just a minute. Okay. So structural part, manipulative part, set of integrity constraints. Set of integrity constraints, actually, there are two types. two types of set of integrity constraints, or two constraints, two specific constraints here. And it says here that there are two other parts, manipulative and set of integrity constraints. Ensure that the data is accurate. We need to ensure that the data is consistent and accurate here, which allows some operations to be, over the manipulation process, even over the manipulation process, there must be some rules to be followed. So there are many other constraints like domain constraints. When we restrict the number of characters, these are also other constraints. What we are talking about is restrictions related to the relational model. These are entity integrity and referential integrity. Okay, so entity integrity and referential integrity. These are two set of integrity constraints. Entity integrity will be related to the primary key, and referential integrity, referential because it's referential, it refers to the primary key. What is it about? Who can tell? Referential integrity will be related to which key? So entity integrity will be referred to primary key. Okay. The referential because it refers to primary key. What other that refers to primary key? Anyone can tell? Yes. Yes, exactly, Ali, foreign key. So the referential integrity, yes, correct. So referential integrity will be related to foreign key. There are other types of integrity constraints, which are multiplicity and general constraints related to domain and so on and so on. But we will focus on, next time, inshallah, we will focus on integrity constraints. Okay, we will focus on integrity constraints. Okay, let's have here a quick questionnaire. I'm gonna record that. Polling, let's say polling. I prefer this study method. Okay, I'm gonna put physical and online. Okay, start. Easy, guys. No, I'm just asking you for the lecture. This is for the lecture, okay? All right. Yeah, I got your point, Ali. It's obvious here. Yalla, 12 also. 12 students did not respond. Okay, 10. Okay. Yalla. Yes. You do both for this polling? No, because the practical instructor will let you know. Sorry, she will provide this. Yep, I know. Okay, if you select both, I'm going to discuss this with the practical session instructor. You mean both? You mean attending? Then we have one lecture, for example. Yes. And the recording, yes, you can see it in the recording. So far, there is no response for 10 students. 10 students did not respond yet. Hello, wake up. Yeah. Of course, Yusuf, still we will have recordings even if we are in campus. We will have recording. I'm gonna have this lecture also recorded. يعني I will be sitting in the desk, okay, near the desk, and then I will bring my laptop. I'm gonna record same way. But maybe there will be more tools to be used in person, like face to face. We will have some discussion groups. We will have more interesting activities. Yeah. I'm trying to make you feel excited to come to the campus. We will meet, we will discuss face to face. Yeah. Still 6 students did not respond. Okay, we can do both. We can do both, but we will focus on there is, yeah, they are encouraging us to encourage you to come to campus because gradually they plan to bring all students to campus till the end of this semester. And no, Abdul-Mannan, it's not a trap, not at all, because life must be back to normal, right? Everywhere now it's the same situation. We must adapt with that. We must get used to it. We must come back. We must go to where we stopped before the pandemic. Yeah, you remember when you sorry, when you were panicking when the study was online. You said no, we don't accept. We don't want that. Stop this. Stop that. Yeah, you remember? It's the same now. Okay, now I have 17 online, 7 physical. Fair enough. Okay, I can print screen. I can put it in the chat. I took 4 more minutes from your time, guys. Thank you so much. Can I have it placed here? No. Inshallah, next course, Qasim. Yeah. Okay. Yeah, I understand. Exactly. If you know that if you have done this before, you would go for perfect timing for your schedule, right? Yeah, I understand. I understand. But still, life is challenging, right? It's an experience. It's something we need to go through. Yes. Ali, you can see it from the recording, and I can have it. Yeah, okay. I'll send the prints. I'll send the screenshot now in the chat. Okay. Yes, you can still join. Yes, you can still join like you are welcome anytime. I'll be there. I told you, starting from the next week, Sunday, I'll be there. You will find me in 028. Okay, it's 40-028. I will be sitting there within the lecture time. Okay, I will share this. Sorry, because I took 5 more minutes from your time, but just let we have this screenshot. I will share it. What is it? Captures, pictures. I don't know where I kept it. Where I kept the screenshot. Just a minute. Let me just. I cannot paste it even in this chat box. It's not flexible. Okay, okay. Oops. No. I don't know what I have done here. Okay, anyway, I will try to share it. Anyone can? It's not there. I don't know where. Okay, anyone can contact me on Teams. I'm gonna share this. Yes, please, if you can. Ah, I can share the screen. I can still share the screen, right? Okay, this is it. No, you can see it. This is it. Okay, there will be no names here. Yeah, you can see it already, and maybe it's hidden here. Sometimes when the student is not selecting this, see? Sometimes it's hidden view. Well, and it's not there. Okay, anyway, you know the result now. 17 out of 30 selected online, more than half. But still, you are welcome to come to campus, okay? And we will stop here, inshallah. Next time, just let's have a quiz. How about having a quiz by Thursday after we finish this part of the chapter? It will cover chapter number 2, okay? So we will have a quiz 1. It will be online, okay? It will be online. It will be online. Quiz 1 will be covering chapter number 2, okay, on Thursday. How is the activity for chapter number 1? Is it good? 8, 9, 10. Okay, 10th of March. Sure, Qasim, sure, I can do that. Time will be within the lecture time, okay? Let me just record the attendance here, 1, 2, 3, 4. You are okay. That's all. Thank you so much, guys, for your time. I took 9 more minutes from your time. I believe that you have lectures now. Thank you so much. You can leave now.